I'm assuming that I'm not going to see myself show up on the Zoom call here because I don't know how this works. We can just dive into the panel because it looks like we have most of the panelists here. I think the only person I haven't heard from yet is John Adler. Do we know if he's on the call?
I am here.
Oh, perfect. And I can even see you. Cool. So this panel is about MEV in the coming cross-chain world. We only have about 30 minutes for it, and we have 5 people. So I'm going to try to get through the introduction really quickly so we can just dive into questions. I'm James Prestwich. I'm going to be moderating the panel today. I'm lucky enough to have with me 5 people who work on layer 2s, rollups, and cross-chain environments like Cosmos and Celeste. Throughout the panel, I'm going to be trying to say cross-domain. Some of these things are not strictly speaking chains, although a lot of the semantics for connecting them are just the same. So whenever I say cross-domain communication, just think cross-chain. I'm just trying to be a little more technically accurate. So I know that each of the panelists has a lot of opinions on the subject. I'm going to give each of them just a minute up front to talk about themselves, their project, and give a brief introduction. Could we start with Zaki?
Cool. So I wear many hats. I think in this particular domain, I'm wearing the Cosmos IBC hat, representing what sort of the live internet blockchain, like communicating like client system of inter-blockchain communication.
Great. John, do you want to go next?
Sure. Hello, everyone. I'm John Adler. I'm with Celestial Labs, where I do protocol specification and research. And I guess I also wear several hats. And in this case, I guess I have been brought on to talk about things like shared security models when it comes to cross-domain communication.
Ed?
Hi, everybody. I'm Ed Felten. I'm co-founder and chief scientist at Off-Chain Labs, and we make Arbitrum, which is a layer 2 scaling solution for Ethereum.
Ellie?
Ben-Sasson, co-founder and president of Starkware. We use ZK Starks, which I co-invented with some of my co-founders to solve scalability on StarkNet.
And Ben?
Hey folks, I'm Ben, co-founder at Optimism. We're building optimistic Ethereum, and I will similarly take less than my minute allotted time. Well done, panelists.
We're moving through things quickly. I think it's interesting that we have a split of people, John and Zaki, who are working on multi-chain environments and other like non-Ethereum things. And we have primarily Ethereum-based rollups, which are split between the Optimistic with Ben and Ed and the ZK with Ellie. So I kind of want to start off by talking about the technology a little bit. For each of you, how does your system handle cross-domain communication? For the rollups, how do you communicate with the layer 1? And for the Cosmos and Celestia, what does that even mean in your environment? And let's go in reverse order. Can we start with Ben?
You can indeed. You can indeed. Yeah, so in layer 2s, right, where we're kind of, we have this L1 running the show where the data is coming into and disputes are going to be handled if necessary. Basically, the L1 is that source of truth. So the way that we do, and so the cross-domain messaging is sort of based in that L1. So we have 2 kind of levels of cross-domain communication in our system. The first is a lower level one, where but the interfaces are very similar, and it's about the properties that these 2 bridges give you. So at the lower level, you basically have any smart contract or account on layer 1 can send in a message which specifies a target, some data, and a gas limit. And that will eventually be included as a call in the L2 chain, or domain, I should say. And yep, so that's what it is. And then you have an opcode in the L2 VM that lets you access who on L1 sent that call. So this has, there's one tricky part with L2s, which is that you can be out of gas and you kind of can't know about it on L1, right? Because you have to impose a gas limit on L2, and because the whole point is that L2 is a separate environment. L1 can't know about it. So basically, we add an additional layer of messaging, which is like really what's exposed to devs, which has the same properties, but basically wraps everything in a system that enforces atomicity. So it might be the case with that lower level message sending that a smart contract might send a message in, but on L2 that basically times out or can't be run because you're out of gas, the chain is too congested at the moment. So we add in another layer of messaging that gives you atomicity, where if you pass the message in, it's guaranteed to be received at some point in the future.
Some point in the future.
Some point, that's right. So that's kind of the two levels of cross-domain messaging that we have.
Cool. And let's go to Ellie. How does the Stark-based rollups handle cross-domain communication?
So currently, we have a few different systems that are live in production, and the way that there's cross-chain communication right now is basically through layer one, in the way you would imagine it, that you pull something out and you take it in from the other side. So yeah, and I like to speak more about what we actually have and more about what might be in the future. So I mean, yeah, I'll just stop here. We'll have better cross-chain communication directly between things, but when it's ready, we'll be able to discuss it. But yeah, that's the way we do it right now.
Mm-hmm. I think it's for people who might not be aware, how many different production systems is Starkware running right now?
Currently, we're running 3 production systems. Spot trading, it's diversified. DYDX does margin trading or perpetuals. And just one second. And I'm at home with my kids. And Immutable X does minting and trading of NFTs, also third party. So they have a whole ecosystem running there. And very soon, Sorare is going to go live, which is going to be another NFT based thing. So 3 right now, in a few weeks 4. Yeah,
very cool. Ed, same question. How is Arbitrum handling communication with the L1?
Sure. So some people will use specialized cross-domain functionalities like cross-chain atomic swaps and so on that would work pretty much across any pair of chains. But the general purpose cross-domain communication and call mechanism we use is basically one that allows a contract that's running on one chain to send a call to the other chain. So that's call data, call value, and a destination. Because the L1 and L2 run asynchronously from each other, what you get is that you can know synchronously that your call has been enqueued for the other chain, but it does run asynchronously, which means it will run, but you don't get to see the result within your own transaction. And this is true in both directions. A contract on either chain can make a general call to any contract on the other chain by this mechanism. And then there's other functionalities built on top of that, such as token bridging.
Mm-hmm. Is that generally true of all isn't that generally true of all cross-domain communication, that everything will run asynchronously?
Pretty much. I think when you're talking about a roll-up type of approach, asynchrony seems to be necessary, at least without. If you were to lockstep things together more, it would have side effects that you wouldn't want.
Mm-hmm. Okay. And John, I think you're up next. Celestia, what is the concept of a domain and how do you communicate between them?
Sure, thanks. So for those unfamiliar, I'm going to do like a 5-second spiel of what Celestia is doing, because otherwise my answer will make no sense. Essentially, it's the first and currently only general purpose data availability chain. It's a chain that's specifically built just for data availability throughput. It doesn't execute any transactions. And before Dancrad crucifies me for saying general purpose, we can also call it overhead minimized. And because it doesn't execute any transactions, it doesn't actually have any notion of bridges with anything else enforced inside its VM, because it has no VM essentially. So what this means is you can build applications on top of Celestia that leverage it for shared security, and those applications can define their own mechanisms for cross-domain communication. and Celeste does not enforce anything. So to give an analogy, it would be like asking Ethereum, how does it handle a cross rollup communication? Well, it doesn't, because it's a credibly neutral layer that you can build applications on top of. Similarly, Celestia doesn't enforce anything around cross application communication. However, it does provide certain interesting things when you're dealing with cross-domain communication. Namely, it allows shared security, and what that means, it's a shared timestamping server. So imagine if you had like a BTC relay or some sort of Bitcoin relay, where you still have to do fraud proofs or block header validity or transaction validity and stuff, but you just straight up didn't have to deal with Bitcoin reorgs. Right? You just completely remove reorgs out of the equation. And both chains can proceed in lockstep. That if you try to reorg one chain, you would also, as a consequence, reorg the other chain. That kind of stuff can really help cross-domain communication, and it allows general purpose chains to leverage the same nice token and smart contract call bridges that systems like Starkware and Optimism and that Arbitrum have been doing. You can leverage those kinds of mechanisms between more general purpose chains, so long as you have the shared timestamping server.
Mm-hmm. So in a lot of ways, it's similar to a framework for rollups and for communicating between rollups.
You could say that, yes.
Okay. And Zaki, let's finish off this round of questions with you.
So IBC, which is Cosmos's flagship inter-blockchain communication protocol, is an asynchronous packet-based system between blockchains that have sort of fast finality between them, and primarily exists between Tendermint ecosystem blockchains. Let's see, what are the other sort of, I think right now, one of the coolest things about IBC is its general tolerance for failures of any sort of intermediaries. So like the chain that you're communicating may have lost liveness. The chain you're communicating, there may not be a live relayer between them. And we have like reasonable failure recovery paths between all of these things, which I think is relatively cool and unique, and is running in production right now. And people are sending like tens of thousands of IBC packets every day, which is kind of cool.
Very cool. So this is more of an open question for the group. Are there any specific apps that we're seeing use cross-domain communication? I think a lot of us have talked about token bridges as how do we get assets from one domain to another. Are there any other applications that we think are going to use this? And anyone can just jump in here.
Yeah, I'll jump in. So in addition to token bridges, a common design pattern that we're seeing is applications that want to exist on multiple chains, say on L1 and on Arbitrum, using one of two patterns. Either they're sort of homed on one of the chains and open up a sort of branch office contract on the other one, where the home is the ultimate source of truth, but they allow people on the other chain to have whatever functionality their application provides. And we're also seeing some that are genuinely dual homed, where you have a contract on each chain, and those communicate with each other through a combination of out-of-band mediated communication and also the on-chain supported cross-chain functionalities, and they're jointly providing functionality. So we're seeing people, especially in the DeFi space, building a lot of interesting things in this design pattern.
Do you have an example of the second pattern?
So an example of this, so I don't want to name specific names, but we are seeing people who have token-based systems, for example, that can do minting and redemption type of activities on both chains. So it's not the case that you have to transfer your tokens to either particular chain in order to do those things, or that you can only mint on one. So that's a simple example.
Interesting.
I can offer another example with respect to, or a class of things that could come either from L1 or from other L2s going towards Starknet. So I think, the main advantage of something like Starknet is that you can really compress both computation and the non-deterministic witnesses that are needed in other things, both L1 and other L2s. So you could sort of have a situation where you want basically to relay or ask, from L1 or from some other L2 Starknet to run this computation. Let's say, a VDF or an auction or something that has compute something, an average based on many Oracle price feeds and things like that. And if you would have done it either optimistically or on L1, you would have paid either for the computation or for the computation and the transmission, depending if it's on L1 or some rollup that needs to put all the data. And so I could see those kinds of bridges as well. And so these are non-token bridges. These are basically bridges or the communication where you want to rely on the ability to compress computation and call data on something like Starknet. So, I mean, they don't exist right now, but they exist implicitly, like, DYDX relies on multiple computations of price oracles, and all of the signatures are abstracted away. But I could see use cases where, there's demand from it from L1.
So kind of the general thing there is that you're using the cross-domain communication to communicate about the validity of some computation, right?
Right, and non-deterministic witnesses that maybe you don't want to verify on chain.
Right. Things like large batches of signatures, you can just drop from the message entirely. Got it.
Yeah.
Very interesting. Any other examples of cross-chain applications that we're seeing?
One of the things that the Cosmos ecosystem is most excited about is what we call interchain accounts, which is basically taking the idea of like a smart contract account or a smart contract like wallet and extending it to the idea of an entire blockchain can be represented as an account on another blockchain and has all the powers of all the capabilities of like the native blockchain on the other blockchain system. It's sort of, it's like, it's probably less abstract than the other examples that people have been giving, but like, I think it's like, shows like the level of excitement about it shows the demand for things beyond token transfers generally.
So the idea there is basically that this other domain has an account and can call contracts or perform any like normal blockchain action.
Yes.
Very interesting. Yeah,
if I can just, I wanted to add, James, that like another specific example of the kind I said is just voting. So you have a bunch of stakes, let's say some ERC or governance token, you want to collect votes. If you do it on L1, it's going to be very expensive. You could ask Starknet to do that for you.
So you could take something like snapshot and turn it into Stark-based, proof that the vote occurred.
Yeah.
Okay. Very cool. So we've identified a few cross-chain applications, things like attesting to validity, allowing a blockchain to control an account in another blockchain, DeFi apps that are homed on multiple chains and can perform all of their functions there. Are there specific ways that MEV in this application differs from MEV within a single domain?
I'm willing to go first and say something obvious, which is that even like in the conventional financial world, apparently a lot of the arbitrage and high frequency trading is connected to having different systems or exchanges or markets where things are happening, sort of connecting the dots and acting on them. I think MEV has this aspect to it, which is that you even can manipulate or do things. So the more places that you have where things could sort of be manipulated, then of course it just raises the possibilities. But this is just a general state. So like if you could influence, both the sequencing at one place or the transactions or the mempool in one L2 and then in another side chain, then of course you could have even more arbitrage opportunities. But this is, I think we'll see it in the future probably.
This kind of ties into what Ed said earlier about computations running asynchronously in all these environments.
Sure, and yeah, let me jump in. I think Ellie was talking about the sort of combinatorial explosion of different MEV strategies and levers that happen when you have more than, say, 2 chains or domains. But even in the case of 2, I think, like the L2s, I think the rollups probably are similar to what we see, which is there is a mechanism which determines the order of transactions or incoming inputs to our rollup chain. And that really is the mechanism that that establishes order and where the MEV and fairness questions are going to be dealt with. And that's because if it's an L1 to L2 call, then you have an L1 contract that wants to put an event into the inbox of the L2 contract, and that's essentially goes through that ordering mechanism. And if it's something that happens at L2, well, L2 transactions are ultimately triggered by inputs that come in and also go through that ordering mechanism. So there's that single ordering mechanism. I think that would be true of other rollups as well. And so the question is, how do you handle that? Because that's what determines ordering and MEV and fairness consideration. So, we've devoted a lot of attention to how we do that in a way that reduces the amount of value that gets extracted from users and that is as fair and transparent as we can make it as we evolve over time.
So the problem here, if I can restate, is that messages between domains and messages to a specific domain can be interleaved.
Yeah.
Arbitrum has a shared ordering mechanism for these, but other like cross-domain systems might not.
Yeah.
So given the example of like IBC, there is probably no global ordering of IBC messages between domains, right, Zaki?
No, there could not be.
And for Optimism, for example, there could be, does Optimism maintain a separate mempool that is ordered separately from incoming L1 messages?
Yeah, we do. It's an interesting question, a great discussion. I think one of the interesting, I will call out one difference between cross-domain messages and other, just like, within the transactions within the L2. Ed's definitely right that like at the end of the day, the L2's ordering is determined by some like mechanism, which is on L2. One interesting thing though, is that mechanism is also required to follow the L1 ordering. So one interesting thing that we see is that if you have a transaction, which is just a piece of data that is like an L2 transaction, it's like a user transaction with a signature, then you can attempt to order that like optimistically before it goes on chain and know the outcome. But this is not the case for the finality of deposits, because if a smart contract calls into the chain, that is dependent on the L1's finality. So if you have an L1 reorg, you might observe that a different message ends up coming into the chain because let's say the L1 reorg moved some money away and now the deposit can't actually be deposited. So I think this is worth calling out, that cross-domain messages are going to be more restricted in how quickly we can get them in and choose an ordering for them, because what they are doing is required to depend on the L1 state.
Could I like respond to that briefly? I think there's actually different ways of handling that use case. Question is, do you need to evaluate the correctness of this thing at L1 before you can establish it in order? Do you need to determine whether it will succeed at L1 before you assign it a spot in the order? Or do you assign it a spot in the order and then the result of it is maybe dependent on L1 reorgs? And there's some design choices there which do affect what outcome you get.
So do you think we're likely to see, well, let me rephrase that. I think that we're seeing a wide spectrum of choices here, from a more tight ordering to something like Celeste, where there is no guarantee that any specific message will succeed or do anything. Is that right, John?
Not exactly. So for people, I guess, not familiar, but solutions like Arbitrum, for instance, uses, correct me if I'm wrong, Ed, but they use this inbox style system where anyone can submit a transaction for the rollup and they can submit it into an inbox contract on the L1. Is that correct?
Yeah, that's part of the story. We also have a sequencer which has limited power to reorder transactions in order to make faster guarantees.
Yeah, so you have those two components. So I think what James is alluding to is he's saying that Celeste would only have that first scheme of anyone can submit a transaction and then it come in any order for the L2. But that's not exactly correct, because you can also do batches of transactions. And in fact, you can have entire blocks on top of Celeste. Your application can be blockchain based, and they can have blocks. And you can decide your own sequencer aggregator, or however you call it. And for example, they can be the only ones that have the right to produce blocks for the application. And everyone else, you just ignore the messages that they post. So you can get essentially the same thing that you get out of Rollups on top of Celeste. You don't have to worry about this kind of, anyone can just post anything at any time. But I did want to mention one thing relevant to your question, if that's okay, which is that I like to invoke what I call the law of conservation of MEV when it comes to layers, which is basically that MEV can't be created or destroyed. Well, it can be created. It can't be destroyed. It can only be moved from one layer to another, which is completely not scientific law or anything. It's just an observation, which is basically saying that if you have a rollup, you're not going to have less MEV. You're just going to move the MEV from, the best you can do is move the MEV from the main chain to the rollup, which isn't inherently bad, especially if you use only batch submission style systems and no inbox. Then the layer one doesn't see the MEV. It just doesn't see it because the only people who can submit blocks are these layer two sequencers. That comes with its own set of trade-offs, but you can move the MEV to a layer two, but you can't eliminate it. It'll still be there in terms of quantity.
So the MEV of the total cross-domain system is always increasing?
At the very least, yes. It never decreases.
I don't know that that's true in general, actually. There are degrees of freedom in design that you have in an L2 system that don't exist in the fixed architecture that exists sort of on Ethereum L1. And so you do have opportunities for design that Ethereum doesn't have because Ethereum already exists and has baked in a certain approach. So I don't think it's at all Ethereum that you can't reduce MEV. It's not easy, and if you're just careless about it, you probably will maintain or maybe even increase the extractable value. But you can do better if you're willing to innovate in design.
So I should clarify that when I'm talking. Sorry, very, very quickly, if you don't mind. I should clarify that the observation I'm saying is mostly about if your layer two functions the most naive way and exactly the same as the layer one, then you're not removing MEV. Of course, just like how you could change the layer one to reduce MEV, you could also apply those changes and experiment with new techniques for sequencing, aggregation, MEV reduction on the layer two. But that's orthogonal to the fact that it's a layer two. Like you could do those same things on Ethereum if it wasn't for the fact that it needed to maintain backwards compatibility.
Okay, so this kind of segues nicely into the last thing that I wanted to talk about before we wrap up the panel, which is whose job is it to reduce MEV? Should it be the job of the system developer or the job of the application developer? And when we get into these cross-domain systems, who has to do all of the work to minimize MEV and communication between them? And I want to, because we're wrapping up, I'd love to do this last one kind of round robin, give everyone a chance to speak again. And let's start with Ben.
Cool. I mean, it's a great question, James, and it's the philosophical one that I think will get thrown out on every single MEV, Flashbots talk from now to the end of time. I think the responsibility is on both parties, and I think that there's a trade-off between doing it within the system in terms of how universal you think those fairness properties are. So I think that the tricky thing is that we don't yet have a result that says that any particular system can have general applications that are MEV resistant in some way by nature of the system. Like it's not obvious at all that it's for any system that is trivial, that like actually can have economic activity, that there's not some application that you can put on that system that introduces MEV. So fundamentally, that seems to put a lot of attention onto the application developer if we don't know yet if it's even possible for a generalized MEV resistant application. There are obviously things that we can do that are very useful heuristics and that feel very fair. It may be different between who thinks what. But fundamentally, some of it has to go on the application, I think, because of the nature of that systemic unknown.
Interesting. Ed, do you want to go next?
I would agree with Ben that it has to be everyone's job because it's a hard problem and there are hard trade-offs, right? So system design should be trying to reduce or mitigate MEV as much as possible, but then there'll be some part of the job that will fall onto applications. But it's also important for the system designers to create affordances that are useful to application designers so that they can fight the particular MEV or front-running issues that afflict their applications. So it's not just a sort of fighting it separately in each layer, it's also about what can the base layer do to help the application developer have the tools they need.
Ellie?
So I take my inspiration from what happens in the conventional markets. There, you're under the assumption that if there is a flaw, someone will use it and try to, front run or do whatever, wash trading or things that are illegal. And then it's the sort of at the system level, you ban it by law and regulation. The analogy to that is that I think it is, of course, it's objectionable to front run and do things like that. And, operators and whatnot shouldn't be doing it. But I think you would like, in a decentralized, protocol-based system, you would like to put maximal effort in getting the protocol to eliminate or reduce, to the maximal extent, the ability to extract value from these things. And then, because especially in this anonymized, permissionless world, it's going to be very hard to assume that DApp developers are going to be moral, it's not the case. So you really need the protocol to solve it.
Mm-hmm. John?
Sure. I would say, and mirroring what Ed said, that the protocol developers, under the assumption here that the protocol is some sort of credibly neutral public good, probably have responsibility to at least build tools so that application developers can minimize the MEV that the applications they build have. I think it should provide appropriate tools for this. And so it is at least partially the responsibility of the protocol developers. I'm not really sure if the application developers have any responsibility. I guess it depends if you're talking about if it's like an ethical responsibility or a financial one. And it depends if the application is a public good or if it's just some financial application. Application developers, and I think the Ethereum protocol developers had to learn this the hard way with things like refunds. The application developers have one responsibility. Assuming the application is not a public good, the application developers have one responsibility, and that's to make money for themselves and to a certain extent for the users, in as much as that makes themselves money. And in that regard, MEV doesn't matter, as long as you can make money. And that's why you see things like gas token happen. So if the application is a public good, yeah, they should probably strive to reduce MEV. If it's not, we shouldn't trust that, we shouldn't assume that they have any such responsibility, in my opinion.
Interesting. And let's wrap up with Zaki.
So 2 things. What we've found is practically attempting to reduce MEV propagates dependencies like up and down the stack. So like the demand to reduce MEV is like changing APIs within how Tendermint interfaces with the application language, which is this idea called ABCI++, that is sort of propagating like MEV related ideas all the way down into like how Tendermint works. And on the other hand, like, yes, MEV is very application dependent, and very much the idea of Cosmos is that people could co-evolve like all layers of the stack to provide the optimal user experience. And to go to like a little bit of like, why would someone want to do this? Why do people care? People care because MEV takes value away from their users and sends it to other parties. And you will probably be more successful in acquiring users if that doesn't happen.
All right. Thanks for your time, everyone. Always a pleasure to see each of you. I think Sunny is up next.